Okay, containing p block element. Yesterday we have discussed 13 group element, that is boron family, their general characteristics, chemical properties and some reasoning. Now containing that p block element, next is 14 group element. Now 14 group element, what are the elements which are present in 14 group? Carbon, silicon, germanium, tin and lead. These are the elements which are present in 14 group. Once again, carbon, silicon, germanium, tin and lead. This entire group is also known as carbon family because the first element is carbon. Okay. Now general characteristics. General characteristic. General characteristic. Number first, electronic configuration. Electronic configuration. Now 14 group element, their general electronic configuration is ns2 np2. That is, the outermost p orbital will contain 2 electrons. If you write the electronic configuration, then the last electron will be present in p orbital, and how many electron will be in p orbital? 2 electron will be in p orbital. Okay, suppose carbon, atomic number of carbon is 6. If we write its electronic configuration, it is helium 2s2 2p2. You see, now it is this silicon. Atomic number of silicon is 14. What will be its electronic configuration? Neon 3s2 3p2. Then is germanium. What is atomic number of germanium? Before germanium, what was placed? Gallium. Atomic number was 31. So this will be 32. It will be argon 3d10 4s2 4p2. Okay, then next is tin. Atomic number of tin. What about tin? 32. You add 18 to it, it is 50. So its electronic configuration will be krypton 4d10 5s2 5p2. Then lead. You add 32 to 10, you will get 82. So lead electronic configuration will be xenon 4f14 5d10 6s2 6p2. Now you concentrate on last p orbital. What has happened in p orbital? That every p orbital is containing 2 electrons. So all these elements fall under which group? 14th group. Clear? Next property is atomic size. Number second, atomic size. Carbon, silicon, germanium, tin and lead. Now you all know, you have studied first group, second group, third group. Now this is 13, this is 14 group. Now when we are moving from top to bottom, what is happening? Atomic size increases. It is going to increase. Increases as you come over here. Shell number in carbon, it has 2 shell. Silicon 3, germanium 4, lead 6. So as shell number is increasing, shell number is increasing. So atomic size is increasing. If shell number increases, then atomic size increases when we are moving from top to bottom. Number third, ionization enthalpy. Ionization enthalpy. Now what about the variation of ionization enthalpy? Carbon, silicon, germanium, tin and lead. When we move from top to bottom, ionization enthalpy decreases. Ionization enthalpy decreases. Why it is decreasing? Because it is inversely related with atomic size. Decreases because simple is the reason. Because atomic size increases. Greater is the atomic size, less will be the ionization enthalpy. Lead has a comparatively bigger size, so less energy is required to remove the outermost electron. Carbon atomic size is very small. The electron are tightly held by the nucleus, so more energy is required to overcome this attraction force. Therefore, ionization enthalpy of carbon will be more due to its smaller atomic size. Clear? This was third. Now number fourth property, metallic character. Metallic character. Carbon, silicon, germanium, tin and lead. Now you see, carbon and silicon, they are non-metal. Germanium is metalloid. You know metalloid in class 10. You have heard this word. Metalloid means it can behave both as metal and non-metals. In some property it will resemble metal, in other property it will resemble non-metal. Tin and lead, they are metals. Now what is happening when you are moving from top to bottom? Metallic character increases. In every group the trend is same. Metallic character increases. Why it was increasing? As atomic size increases. Greater is the atomic size, then that element will be metallic in nature. So lead is metal. You are familiar with carbon. Due to smaller atomic size, it is non-metal. Atomic size increases and electropositive character increases. Electropositive character. Electropositive character means tendency to donate electron increases. So if you are comparing carbon and lead, then lead has greater tendency to donate its electron. It can easily lose its electron as compared to carbon. So it has greater electropositive character. Clear? This was fourth. Number fifth, electronegativity. Electronegativity. Now you are familiar with this term. You have studied about electronegativity in lesson number 3. Now what is electronegativity? Tendency of an atom to accept shared electron pair is called electronegativity. So if we are dealing with carbon, silicon, germanium, tin and lead. Now you see, when you are moving from top to bottom, electronegativity decreases. Electronegativity decreases. Why it is decreasing? Because atomic size increases. Atomic size increases. Greater is the atomic size. If an atom has a greater size, then that atom has tendency to lose electron. But what is electronegativity? It is tendency to attract shared electron. So if smaller is the size of an atom, it has greater tendency to attract electron pair toward itself. Therefore, carbon, it is considered to be more electronegative as compared to the rest of the element. Okay. this was number 5. Number 6. Melting point, boiling point. Melting point and boiling point. Now how this property varies? Carbon, silicon, germanium, tin and lead. When you are moving from top to bottom, both these properties decreases. Both these property decreases. Carbon is a non-metal. Carbon has higher boiling point. Has higher melting point and boiling point. Because you know carbon is non-metal. You come to lead, greater atomic size of lead, it will melt easily because the force of attraction between lead molecules are comparatively weak as compared to carbon. Or we can write force of attraction decreases. Force of attraction decreases from carbon to lead. So if forces lead atom is combining, a number of lead atoms are combining to form lead element. So due to greater atomic size of lead, the attraction force between lead atom and crystal lattice is weak. Therefore, this lead has weak melting point, low melting point and low boiling point. Carbon is smaller in size, so carbon atom can combine together. So attraction force between carbon and carbon atom will be more. So it will have greater melting point and greater boiling point. Okay. Now number 7, catenation. Catenation. Now what is this catenation? You heard this catenation in class 10. Catenation, tendency of carbon to combine with itself. Carbon to combine with itself to form large number of compounds. Large number of compounds is called catenation. In class 10, I have told you catenation means carbon atoms are combining with itself, and due to their combination, a large number of compounds are formed, or self-linking property. This self-linking property is called catenation. Okay, carbon, you can see carbon, that is carbon atom are combining with itself, and this compound is known as straight chain. If carbon combine linearly they form straight chain. They can also combine in this fashion, carbon. This is branch chain. So this is a unique property of carbon. So these group element, 14 group elements show property of catenation. They are self-combining with itself. Now what about the variation of this catenation? How this catenation vary when we are moving from top to bottom in 14 groups? Okay, now let us see its variation. When we move from carbon, silicon, germanium, tin and lead, then catenation decreases. Why? Catenation decreases. Why it is decreasing from carbon to lead? Because bond enthalpy decreases as atomic size increases. As atomic size increases, bond enthalpy means if I am writing carbon-carbon bond, carbon atom, they are combining self-linking with itself. Atomic size of carbon is smaller, so they will be closer to each other. Hence, the energy which is required to split this bond will be more. Once bond is formed, it is forming a stable compound. Okay, due to smaller atomic size. But what happens in case of lead? If lead is combining with lead. Now, atomic size of lead is bigger. Both lead atoms are bigger in size when they are brought in close contact with each other due to greater atomic size. Their bond enthalpy is less. Less bond enthalpy. Okay, one atom is here, one atom is here. This bond length is more, so bond enthalpy will be less. Less energy is required to break this bond. Hence, the lead catenated compound are unstable. Once they are formed, by supplying less energy, they split up. So, lead and tin, they do not show catenation property to a greater extent. Maximum catenation is seen in case of carbon and silicon due to their smaller atomic size and greater bond enthalpy. If I tell you the bond enthalpy of carbon-carbon single bond, it is near about 340 kilojoule. Means once carbon-carbon atom is combined, to break this bond, you have to supply 340 kilojoule of energy. That is comparatively very high. Where in case of lead, the amount of energy which is required to split this bond is 200 kilojoule per mole. It is comparatively less. So easily this bond can be broken. So here catenated compound are less stable. Here catenated compound are more stable. Okay. So carbon-carbon have more bond enthalpy. Understood catenation? Clear? This was property number 7. Now property number 8. Common oxidation state. Common oxidation state. This is very important. Common oxidation state. 14 group element, they exhibit common oxidation state of +4. +4 means what? After losing 4 electron, they are forming tetrapositive ions. To become stable, they can lose 4 electron. Okay, metal, it can form this tetrapositive ion by losing 4 electron. But going back to class 10, when you are reading that compound of organic chemistry lesson, carbon cannot exhibit +4 oxidation state. It cannot lose 4 electron. Why? This has been discussed in class 10. It is very difficult for carbon to lose 4 electron. It can neither lose 4 electron, neither it can gain 4 electron due to the principle of energy considerations. So, carbon mainly forms what? Covalent compound. It was in class 10. Okay. So, common oxidation state is +4 except the stability of, now you see this is important, the stability of +2, oxidation state increases from carbon to lead. Now why it is happening so? Yesterday I have discussed, means when we are moving from carbon to lead, +4 oxidation state tends to become unstable, and +2 oxidation state becomes more stable. Why? Yesterday I have discussed this entire concept because it was also happening in 13th group element. It is due to inert pair effect. It is due to inert pair effect. Inert pair effect. Now, going back to that inert pair effect, if you know, you see lead. Atomic number of lead is 82. Its electronic configuration is xenon 4 4F14, 5D10, 6S2, 6P2. This is the electronic configuration of lead. Now, what is happening in lead? These electrons, now you see 4F and 5D orbital are completely filled. Okay. On completely filled, they have poor screening effect. Poor screening effect means, you have heard screening effect in third lesson. These electrons do not screen the outermost electron from the attraction of nucleus. Now what is going to happen if the attraction force is less? This S electron, they are attracted by nucleus. Nucleus will attract these electrons towards itself. As a result, these electrons cannot enter into chemical combination. The inner S electron, yesterday I have discussed this. The inner S electron are tightly held by the nucleus. So they do not enter into chemical combination. They do not enter into chemical combination. So they are also attracted by the nucleus. Why? Due to the F and D orbital being completely filled, these S electrons attracted by the nucleus towards itself. So they do not take part in chemical bond formation. Only this outer P electron are removed. So how many electrons removed? 2. So what will be the common oxidation state of lead? +2. So this effect is called inert pair effect. Okay. So due to this inert pair effect, the stability of +2 oxidation state increases from carbon to lead. Means lead exists in +2 oxidation state. Lead never forms compound in +4 oxidation state. The most common oxidation state of lead is +2. Clear? If I am writing like this, in +4 oxidation state, the element act as oxidizing agent. If oxidation state is +4, it will act as an oxidizing agent. Means what? Metal in +4 will change into +2. Okay, now how this is going to happen? +4, it will gain 2 electron, means it is undergoing reduction. Or this we can write in this form. The simplest way is this. If we write this is M +4, it is gaining electron, forming M +2. Similarly, in +2 oxidation state, if element is in +2 oxidation state, the element acts as reducing agent. The element acts as reducing agent. So now you should be familiar with these things. In +2, this is M in +2. It is acting as reducing agent, means it is undergoing oxidation. Okay, this is very important. If an element is in +4, it will behave as oxidizing agent. If it is in +2, it will behave as reducing agent. Understood? It is due to inert pair effect. Therefore, we can write like this: PbO2 act as oxidizing agent. Why? What is the reason behind it? Strong oxidizing agent. Can you explain it? Why PbO2 is behaving as a strong oxidizing agent? It is oxidizing other, itself it is undergoing reduction. Means PbO2. In PbO2, if I write the answer for this, in PbO2, lead is in +4 oxidation state. You calculate the oxidation state, 2 to the 4 +4 oxidation state. So, it is unstable. It is unstable. It changes into stable oxidation state. Stable oxidation state of +2. So it is behaving as what? I have written over there, oxidizing agent. You can write Pb +4. It gains electron, changes into Pb +2. So this is behaving as what? It is behaving as an oxidizer. It will oxidize other, but itself it will get reduced. Clear? Similarly, now if I am writing this, Sn+2 act as an reducing agent. Why? Can you answer this? Act as a reducing agent. Sn+2. When 10 is in +2 oxidation state, it is behaving as a reducing agent. Why? Because, what is the problem for this? Because it changes into what? +4. And it changes itself into +4 means Sn+2 will change into itself, it will undergo oxidation, but it will reduce other element. Now you can say 10, it is in +4, it is changing into +4, +2 to +4. Sn+2 yani SNO, it is behaving as reducing agent. SnCl2, it is behaving as reducing agent because the oxidation state of 10 is +2. Clear? So this is about common oxidation state. Clear? Next property is chemical properties. Chemical properties. Chemical properties. Number first, action with air. Action with air. Now what is going to happen when these elements will react with air? When these elements react with air, they are forming two types of oxides. These elements on contact with air forms two types of oxides. It is forming two types of oxides. Number first is monooxides. Now you are familiar with this term, monooxides. Monooxide means CO, carbon monoxide, silicon monoxide, germanium monoxide, tin monoxide and lead monoxide. Okay, so they are forming monooxide. In these monooxides, CO is neutral. It is neither acidic nor basic. This CO, carbon monoxide, is neutral. It is neither acidic nor basic. SiO is acidic. and other are amphoteric. Amphoteric means they can behave as both acid as well as base. The rest, germanium, tin and lead oxide, they are amphoteric. Okay. This is monoxide. B is dioxides. The second type of oxide which is formed by these elements are dioxide, carbon dioxide, silicon dioxide, germanium dioxide, tin dioxide, lead dioxide. Now you see they are also forming dioxide, CO2, SiO2, GeO2, SnO2 and PbO2. Now what about the nature of these oxides? What about their nature? You see over there, CO2 and SiO2 are acidic in nature. They both are acidic. Acidic means if you react CO2 plus water, it will form carbonic acid. It is forming carbonic acid. Okay. So this CO2 on interaction with water, they form acid. Similarly, siliceous acid, SiO2 react with water to form siliceous acid. So CO2 and SiO2 are acidic in nature. Germanium oxide, tin oxide and lead oxide are amphoteric. Amphoteric means they can behave as both acid as well as base. They are behaving acid as well as base. Clear? This was first property, action with air. Number 7, action with water. Action with water. What is going to happen when these elements are reacting with water? Carbon, silicon and germanium are unaffected by water. They do not react with water because they are chemically unreactive. They do not react with water. Tin, Sn, reacts with water. This is the only element which reacts with water. So its reaction is Sn plus water forming stannous oxide plus H2. Okay, lead does not react with water. Why lead does not react with water? Does not react with water due to deposition of oxide film on its surface. Lead, it is unaffected by water. It does not react with water because on the surface of lead oxide, PbO or PbO2 is deposited. So lead also failed to react with water. Only one element is reacting, that is tin. Clear? This is second property. Number 3, action with halogens. Action with halogens. All these elements, 14th group element, they combine with halogen. Halogen, it is X2 forming tetrahalides. MX4. The halide form are tetrahalides. Now you know tetrahalide. If you are going to write example of tetrahalide, CCl4, SiCl4, PbCl4, etc. It can be CF4, SiF4. X means halogen, fluorine, chlorine, bromine, iodine. So they all are forming, all 14th group elements are forming tetrahalides. Clear? I have written CCl4 as PbSl4. It can be PbI4, PbbR4, SiF4, CF4. And 4 halogen atom can combine with these atoms to form tetrahalides. Okay. These tetrahalides are covalent in nature. They are covalent compound. Are covalent in nature. All tetrahalides are covalent in nature. What about the nature of tetrahalides? They are covalent in nature. Clear? Now, being covalent in nature, they are soluble in organic solvent. Soluble in, covalent compound soluble in organic solvent. Okay, they are covalent compound. Being covalent in nature, they are soluble in organic solvent. Clear? Now, what about the structure of, suppose I am drawing CCl4. You see here CCl4. Carbon, 4 chlorine atom, 1, 2, 3, 4. There are 4 Cl atom. 1, 2, 3, 4. 4 Cl atom, and these 4 Cl atom are placed at the corner of a tetrahedron. This is their structure. So this carbon atom shows sp3 hybridization. Hybridization. You will read about hybridization in lesson 4, chemical bonding. So all these tetrahalides have sp3 hybridization and their shape is tetrahedral. Shape is tetrahedral. There are 4 bonds. 1, 2, 3, 4. 4 bonds and tetrahedral in geometry. Understood? Clear? Now let us move on containing these halides. There are reasoning in this halide A part. CCl4 is not hydrolyzed. But SiCl4 is easily hydrolyzed. Why? Is easily hydrolyzed. Easily hydrolyzed. Why? This means what? If I have written CCl4 plus water, then no reaction is going to take place. But if I am writing SiCl4 plus water, then this reaction is taking place. SiOH4 plus 4HCl. Now why this has happened? You see, all Cl atom are replaced by OH. The same would have occurred over here. But here the reaction is not taking place. Why? What is the answer for this? Because you know electronic configuration of carbon, because carbon atom lacks vacant d orbital. It does not have d orbital. Vacant d orbital. So it cannot extend its coordination number beyond 4. Coordination number beyond 4. Beyond 4. This means what? If we are writing the reaction, you see over here. This is carbon, 1 Cl, 2 Cl, 3 Cl, 4 Cl. It is combining with water. This is water molecule. This is water. Now, this carbon lacks. What is happening in carbon? It lacks d orbital. It is not having d orbital, so this carbon cannot take the electron of oxygen. Hence, this reaction is not going to take place. It will not occur. Okay, but if you write the same reaction with silicon, let us write over here on next page. If we write the reaction of silicon Si 4Cl 1 2 3 4 plus water. Now you see what is happening here. 1 2 3 4. Silicon atom, it has vacant d orbital. So what it will do? It will take this electron pair. It can extend its coordination number. It is forming 4 bond. It can form extra bond. Why? Due to the presence of vacant d orbital. Now, if it is forming extra bond, what has happened? Carbon, silicon, chlorine. These were the 4 bonds. Now it has formed extra bond with oxygen. Now you see. Yes or no? Why it has formed extra bond? Because it was having d orbital. After the formation of this bond, what is happening? You see, HCl is removed. Minus HCl forming what? Cl, silicon, Cl, and what is left? OH. Now you see, one Cl is replaced by one OH. Similarly, again this Cl atom can be replaced, means if it reacts with plus 3H2O, then minus 3HCl, and ultimately we will get this OH. Now you see, all the 4 Cl atom are replaced by what? Replaced by OH. So we can say silicon have vacant d orbital. So it gains electron, it gains electron from water molecule, forming OH bond. As a result, SiCl4 can easily be hydrolyzed. Understood? If d orbital are present, then they can easily gain an electron. By gaining electron, you see an extra bond is formed after bond formation. HCl is removed, OH is coming over here. Now these 3 Cl atom will also be replaced by 3 water molecule. Ultimately this compound will be formed. So SiCl4 is converting into SiOH4. It is undergoing hydrolysis. Same was not possible with CCl4. Why? Because carbon was lacking d orbitals. Clear? Now next reason is, let us move on. Second reason, carbon does not form complex, whereas silicon have tendency to form complex, Why? If I am writing the reaction. You see over here, CCl4 plus 2Cl negative, then means CCl6 minus 2. It is not possible. This complex compound is not going to be formed. Clear? But if I am writing SiF4 plus 2F negative, then you see silicon SiF6 minus 2. This is possible. This compound is formed. Now why it has happened so? What is the reason behind it? You can write SiCl4, 2Cl negative, SiCl6. Still that compound does exist. So carbon does not form complex, silicon form complex. Why? I have just told you, because the reason is same. Because carbon lacks d orbital. Maximum covalency of carbon is 4. It cannot combine with more than 4 atoms. Okay. Carbon lacks d orbital. So it cannot extend its coordination number, cannot extend its coordination number beyond 4. Coordination number beyond 4. It cannot combine with more than 4 atoms. Maximum atom carbon can combine is 4. Okay. Here 6. It is not possible because it is lacking d orbital. But silicon atom has vacant d orbital. Silicon atom has vacant d orbital. So it can extend its coordination number. It can extend its coordination number beyond 4. Means silicon can combine with more than 4 atoms. You can see here it was combining with 4. Here silicon has combined with 6 fluorine due to the presence of vacant d orbital. Understood? It should be very clear to you. This was B part. Now let us move on to next C part. SiF6 does exist, but SiCl6 minus 2 does not. It is unstable. Why? Why this is not going to exist? Silicon are same. Both silicon atom. Both are silicon atom. This is silicon. This is silicon. I have changed fluorine to chlorine. Now, why this has happened? Why that compound SiCl4 minus 2 is unstable? Why this compound is unstable? Or why this compound is not existing? You see over here. Atomic size of silicon is small. Atomic size of silicon atom is small. So it can combine with 6 smaller F negative ion to form SiF6 minus 2. But Cl atom, it is bigger in size as compared to silicon. So how it is possible that a smaller silicon can accommodate and can combine with a bigger anion? So it is not going to take place. But it cannot accommodate 6 big Cl negative ion in its octet. the compound is unstable. Okay, compound is formed, but that compound is unstable. That compound will split up. Why it will split up? You know, to form a stable compound, the cation and anion should have identical size, should be similar in size. Here, silicon atom is smaller, chlorine atom is smaller, so it can form this stable compound. Here, silicon is very small in size, chlorine ion is bigger in size. So silicon cannot combine with 6 big Cl ion. Therefore, this compound does not exist. Understood? One reason is this, or we can write another reason, the steric repulsion of F negative ion is smaller than Cl negative ion. Okay, Cl negative ion bigger in size, they will repel each other. F negative is smaller in size, steric repulsion will be minimized. So this compound is stable and this compound, it does not exist, or that compound is unstable. Clear? Understood? You should not have any doubt in this halogen portion. Okay, now moving on. Next property was number 4. Allotropy. You are also familiar with this. Allotropy. Do you know what is allotropy? You are hearing this word since class 7. Allotropy, allotropy, allotropy. What is allotropy? We are dealing with carbon family. Allotropy means the property of a compound element, the property of an element to exist, property of an element to exist in more than one form, having similar chemical property, but different physical property, This phenomena is known as allotropy. Okay, an element can exist in nature in more than one form, but in those forms, the chemical property are going to remain same, but their physical property will be different. Then that phenomena is known as allotropy. Clear? I am writing over here. You see, allotropes of carbon. In class 10, you have also learned that allotropes of carbon exist in allotropic form diamond. You are familiar with this graphite, okay, coal and fullerene. These are the allotropes of carbon. Carbon in nature can exist in these 4 forms, but their chemical properties are same. Means diamond is represented as C, graphite C, coal C, fullerene C. If you react all these with air, they are forming carbon dioxide. Understood? But their physical property are entirely different. You have heard about diamond and graphite. Diamond is hard, graphite is soft. You know it very well. It is bad conductor of electricity, good conductor of electricity. It is lustreless, it is non-lustreless. So their physical property are different, but their chemical property are entirely same. This property is known as allotropy. Understood? Clear? So that's all for today. Tomorrow we will discuss a few questions which are left in this P block element. So please, once again I am telling you, whatever I have taught you, you note it down in your fair copy and revise it thoroughly. That's all for today. We will continue tomorrow. Thank you very much.